Welcome back to our math course. Now we are going to go through chapter 24, measuring, drawing angles and bearings. So at first, let's rewind what we already know about measuring and drawing angles. First thing, acute angle. Acute angle is the angle that has the value that less than 90, for example 16 or 40, or even 89.999 is an acute angle. The second thing is obtuse angle, which is between 90 and 180 degrees. For example, we have the degrees of 130, which is less than 180 and larger than 90. The obtuse angle often bigger than the acute angle. You can see that. The third one is the reflex angle. This one is a bit difficult for the one who need to rewind this a lot, because it is sometimes you need to calculate it, or sometimes you need to see it by your mind. For example, we have the 300 degrees. The reflex angle is different from other angles because it is the angle that outside of the line. For example, the whole turn of circle have the angle of 360 degrees, which is 60 degrees here, and the reflex angle of that angle is 360. 360 subtract 60 is equal to 300. And what happens if we have two lines that cross together and make a parallel? We have no angle for that one, but let's think about something special. What do you think about right angle? The right angle is made when two lines are perpendicular. When two lines are perpendicular, we say that it has 90 degrees. Okay. So let's talk about this a little bit. We have a line here, and let's rotate it. So the one rotation of the line, which is 360 degrees, which means that this is the whole circle. So what happens if we cut it in half? If we cut it in half, the degrees in each side of the circle will be 180, just because it is a half of 360. So the line and the angle here, it has its name, like a flat and straight angle. This is the name of the angle that has the number exactly 180. So what happens if we split it to 4 parts? So what is 360 multiplied by 4 or divided by 4? Okay, so 360 divided by 4 is equal to 90, right? So we have 4 parts here, which means that each part has the angles of 90, which is the right angle. So let's talk about the usage of the protractor. Protractor, we use protractor as a measurement that to find out the angle of the shape. For example, we have two lines here. As you can see, this is an obtuse angle, and it has 140 degrees. So what is the rules here? What are the rules are here? First, place the center of the protractor exactly on the corner of the vertex of the angle. This is really affect your method, because if you have it wrong, then your method will be wrong. The second thing that you need to remember is lay the baseline of the protractor on top of one side of the angle. This will make sure that your line will not go out too far and on the exact base. And this is the symbol for the angle. For example, we have the angle 140 here, so there will be a symbol of the angle here and 140. Next, we will talk about bearings. So what is the bearing? Bearings of the point, let's make an example of point B. So the bearing of the point B from point A is the angle through which you turn clockwise as you change the direction from the north to B. So from north to B is the bearings of point P from point A. So let's take an example here. If we move the line BA far from NA has a degrees of 16. This is the bearing. The bearing happens when you turn and rotate the line in the clockwise direction. A bearing can have any value from 0 to 360. A 3-figure bearing is needed to present a number in the bearings. For example, we have 60 degrees here, which need to be written as 060 degrees. If we have 140 degrees, it is still written as 140 degrees. So what do you need to remember here? Just remember the rules. There is the rules called the 8 bearings. From northeast is southeast, southwest, west, and northwest. In each of these bearings, you just need to plus this by 45 to have each of these 8 rules. Thanks for your watching, and hope you can learn this a lot.
Hey guys, welcome to Unit 24.3 of Nets. Let's start with some solid shapes that you should already be familiar with. We will start our revision with a cube. It is a 3-dimensional or 3D solid object bounded by 6 square faces. Next up, we have a cuboid. It is also a 3D shape with 6 faces and form a convex polyhedron. Broadly, the faces of a cuboid can be any quadrilateral. A prism has a uniform cross-section, just like a triangular prism or a hexagonal prism. Last but not least, a pyramid has a polygon-shaped base. The other faces are triangles and meet at the vertex. Each of these solid shapes can be made from a net. Well, of course not these nets. A net is a flat shape which can be cut out or folded to make a solid shape. So let's learn some vocabulary. What is a net? A net is a pattern that you can cut or fold to make a model of a solid shape. For example, the net for the square base pyramid, a cuboid, a hexagonal prism, or just as simple as a cube. Let's do a practice together. Here's a net for a cube. How many different nets can you draw for a cube? Hint, there are 11 altogether. Hey guys, welcome to Unit 24.4 of Congruent Shapes. First of all, let's go back to 24.3. Were you guys able to get all 11 nets? Well, here's the answer. Now into today's lesson of congruent shapes. But first, vocabulary. What is congruent? It is the word to describe when two-dimensional shapes are exactly the same size and shape as each other. For example, although they're in different positions, the triangle below are all congruent because they're all exactly the same size and shape. Congruent shapes fit exactly on top of each other, so one way to see whether the shapes are congruent is to trace one of them and check that it covers the other shapes exactly. Now it's time for a practice. Here are some pairs of shapes in different colors. You tell me whether each pair are congruent shapes or not.
Hello everyone, welcome to Mathematics online lesson. Today's lesson is 34.5 and 34.6. This online lesson is produced by me, Mạc Minh. The first one is 24.5 congruent triangles. Two shapes are congruent if they are exactly the same size and shape. Congruent triangles can be differently oriented. It means that reflected or rotated. Conditions for congruent triangles. Condition 1. All three sides of one triangle are equal to the corresponding sides of the other triangle. The condition is known as SSS, means side by side. Condition 2. Two sides and the angles between them of one triangle are equal to the corresponding side and angle of the other triangle. This condition is known as SAS, means side angle side. Condition 3. Two angles and the side of one triangle are equal to the corresponding angles and side of the other triangle. This condition is known as SASA, mean angle side angle. The fourth condition is both have a right angle, an equal hypotenuse, and another equal side. This condition is known as RHS, mean right angle hypotenuse side, and only used for the right angle triangle. There are some notation. Once you have shown that triangle ABC is congruent to triangle PQR by one of the above condition, you will have angle A equal angle A, dot, and you will see all the three. You can write two congruent triangles as triangle ABC congruent to triangle A dot B of C dot. There are some exercise and you can do it later if you want. Similar shapes. Two shapes are similar if one is an enlargement of the other. Corresponding angles of similar shapes are equal. As you can see in the picture, the ratio is 2/3. There are some exercise for this and you can do it later. Thank you for watching.
So today I will be presenting two units, 24.7 area of similar triangles and 24.8 areas and volumes of similar shapes. So let's start off with 24.7 areas of similar triangles. So we need to identify the similar triangles. So there are two triangles, triangle ABC and DEF, and these two triangles will be similar if the corresponding sides are equal to the ratio of K and the corresponding angles are equal to each other. Next off would be areas of similar triangles. This is two triangles ABC and DEF, and since their corresponding length are equal to each other through a ratio of K, or the linear scale factor of these triangles is K, we can conclude that therefore the area scale factor is K to the power of 2. This is another example of similar triangles. So for instance, to calculate the area of triangle DEF, given that triangle ABC and DEF are similar triangles, so we are given that these two triangles are similar, we can find out the linear scale factor is DF over AC, which is equal to 18 over 12 equal to 1.5. Therefore, its error scale factor would be 1.5 to the power 2 equal to 2.25. And by so we can calculate the area of triangle DEF is 40 times 2.25 equal to 90 centimeters cube square. Example would be 24.8, areas and volumes of similar shapes. First off, by identifying the similar shapes. So solid shapes would be similar if its corresponding lengths are in the same ratio of k. For example, here, these two shapes are equal to a ratio of k, which is 5, and its corresponding angles are equal. These are some other examples of similar shapes. Moving on to areas and volumes. So since they have the corresponding length or in the same ratio of k and the corresponding angles are equal, we can conclude three things. First off, length ratio will be equal to k. Secondly, area ratio will be k to the power 2. And finally, the volume ratio will be k to the power 3. So we will have some examples. So to calculate the volume, the area of these two cubes, first of all, we need to calculate the length ratio, which would be 10 over 5 equals to 2, and then the area ratio would be 2 to the power 2 equal to 4, and the area of the smaller cube would be 5 times 5 equal to 25 centimeters square. And finally, the area of the bigger cube will be 25 times 4, which is the area ratio equal to 100 centimeters square. This is another example of rectangles. We can calculate the area of these rectangles through these using the similar shapes ratio. So first off, by calculating the length ratio, 14 over 7 would equal to 2. Then the area ratio, 2 to the power 2 equal 4. The area of a smaller rectangle would be 3 times 7 equal to 21 centimeters square. Then finally, the area of the bigger rectangle would be 21 times 4, which is the area ratio equal to 48 centimeters square. Moving on to exercises. So these are some exercises on the topic we just learned, and I would give you the answer now.